All right, first section we talked about antiderivative. Antiderivative means go backwards from the derivative. So something like this, which we are gonna do tomorrow. But basically that symbol just means integral, or we are trying to figure out, what was the original function. Now we're gonna talk about Riemann sum today. Riemann sum is antiderivative, or it's a way of trying to figure out the antiderivative of a function. So what antiderivative is trying to do is it's trying to approximate area under the curve. Antiderivative is trying to approximate area under the curve. So remember that we talked about two things last year when we were doing the calculus section in pre-calc. We said derivative is finding the slope of a function. Integral or antiderivative is trying to find the area under the curve. Now Riemann sum is a way of finding the area under the curve, but it's not accurate. Like if you watch the WSQ video, you can see that it's not very accurate, but it's a way of finding it, or at least a start. Okay, so Riemann sum is a very basic way of trying to figure out the area. All right, so let's look at this question. Find the area enclosed between the curve square root x, x-axis, and from x equals 1 to 5 using 4 intervals. All right, so they want us to find the area between this curve, square root x, the x-axis, and then between 1 and 5. So basically, they want us to find this area. Well, we have no way of actually finding the exact area. And this one, they actually only wanted us to use 4 intervals. So we can use Riemann sum. There are 4 types of, or 2 Riemann sum, they call Riemann sum. The other one is called a midpoint sum. The last one is trapezoid sum. So we're gonna do each one by one. First one, let's do left Riemann sum. Okay, left Riemann sum means we are going to create rectangles where we use the left-hand side of the rectangle as the height. Okay, so they want us to do this between 1 and 5. They want us to do this between 1 and 5, where we are using 4 intervals. So the question is, how wide is each rectangle? 1. How did you know it was 1? So between 1 to 5, divided evenly into 4 intervals. Each one has to be 1 long. Okay, or the size of the length of the base, delta x, is the same as the end point minus the starting point over how many intervals they want you to have. Okay, so this is the end point, this is the starting point, and this is the number of intervals. Right? It's pretty intuitive. You take the end minus the beginning and then divide by how many they want you to have. So this is 5 minus 1 over 4, which is 1. So each one of those rectangles is going to be 1 wide. All right, so let's go ahead and draw this in. So you can probably draw this on the paper. So we're going to use left Riemann sum from 1 to 5. So we're going to divide this into 4 equal sizes like this. And what's going to happen is we're going to draw this so that the left-hand side of the rectangle goes up to the curve, and then you draw a straight line through to create the rectangle. So we're going to start at 1 because that's the left-hand side of this interval. So this is the interval. This is the left-hand side. We're going to go up to the curve and then draw a rectangle. All right, and then we do the same thing with that second interval. From between 2 to 3, we're going to use the left-hand side because this is the left Riemann sum. So the left-hand side, which is 2, we start at 2, goes up to the curve, curve over, and then come down. Okay, and then same thing, 3 to 4. Start from 3, goes up, and then down. And then the last one, start from 4, goes up, and then down, like that. Okay, and then we want to figure out what is the area, the sum of those 4 rectangles. So I kind of help you here. Intervals. So interval, the first interval is between 1 and 2. The second interval is between 2 and 3, 3 and 4, and 4 and 5. The x values we're using, it's the left hand. So it's going to be the left-hand side of the interval. The height of the rectangle has to do with the left-hand side. For example, how high is the first rectangle?
1.
1. How did you know it was 1?
Plug into the fx.
Yeah, plug into ffx. So if you don't have a graph, how would you be able to tell how high this is? Well, they tell us this is square root x. So the left-hand side has to do with the left-hand x. So this is square root of 1, which is 1. Okay? You guys are all good, right? This is pretty simple. Okay, and then so square root of 2, square root 3, square root 4 equals 2. All right, now time for us to kind of figure out the area. The base is all 1. We said each interval is 1. So what we're going to do is do base times height. So 1, square root 2, square root 3, 2. The total area is just add up all the numbers. So go ahead and use your calculator and add up all the area. Okay, what'd you guys get for the area?
6.14626.
Okay, 6.146. All right, so that is the left hand or left Riemann sum. Is it a overestimate or underestimate or exact of the actual area? Underestimate, right? So why is that? I guess if you guys can come up with a
Because there's like a missing part.
There's missing part, and also maybe something you could say is that the function is increasing, so that if you're taking the left-hand side, you're always going to be smaller. Yeah. All right, let's try another one. This next one is the right Riemann sum. Okay, I think you guys can do this one. So it's still from 1 to 5, but this time we're going to use the right-hand side of each interval. If you can find the area without filling out the whole table, do that, because that's what I want you to do for homework. You don't need the entire table in order to solve this problem. All you need to do is somehow figure out what is the area for a right Riemann sum. Okay, so this time, because it's the right-hand side, we are using the right hand of all the intervals. So then the height has to do with the right-hand side. base is still 1. Multiply them together and find the area. So what do you guys get for the area of this one? 3/8. All right. I'm going to add one more digit because we want to have 3 digits after the decimal. Okay, is this a overestimate or underestimate or exact? Overestimate. Right, so we're using the right-hand side, which is increasing, so it's getting bigger, and so it's an overestimate. Okay. All right. Let's talk about how we can solve this a little faster without this chart. Okay, so essentially what we're doing is we're taking the base times the area plus base times area plus base times area plus base times area, right? Right? So basically base times area plus base times area plus base times area and so on. And if you have more intervals, that's what you would do. Right? Window? Did something wrong? Huh?
Base times height.
Base times height, sorry. So what you can do is factor out all the base. And then just take all the heights. And then add them together, right? Okay, and then we're going to do some more manipulation with this formula tomorrow. But for now, just know that this is a faster way for you to figure out the area of a right hand or a left hand Riemann sum without actually filling out a chart. Just the base times the sum of all the heights. And how you find the height is up to you, whatever is easier for you to list out all the heights. Okay, next. Midpoint. All right, midpoint is a little bit confusing because we're not looking at the endpoints anymore. We're looking at the middle. Okay, midpoint means, for example, this one, between 1 and 2. We're going to take 1.5. And it goes up to the point on the curve, and then we draw a rectangle. The middle. Not 1, not 2, but 1.5, which is the middle. Okay, and then we do that for the rest of them. All right, when you fill out the chart or when you're trying to figure out the area, now what you're doing is you're taking the height from the middle. Okay, so for example, in the interval between 1 and 2, you're taking 1.5 as the x, and f of x is going to be square root 1.5 because that is the x we're taking this from. Base is still the same because we're keeping it to 4 intervals, and then area is base times height. Okay, so go ahead and figure out what the midpoint area is. Okay, so this area is basically 1 times square root 1.5 plus square root 2.5 plus square root 3.5 plus square root 4.5. Okay, so wherever that number is, what'd you guys get? 6.798. Okay. Last one, trapezoid. I forgot to label this. This is midpoint. Last one is trapezoid. Trapezoid gives us the kind of the best area, but it really depends on the graph. Trapezoid, we have to memorize the trapezoid area. Do you remember the area of a trapezoid?
Base 1 times base 2. Wait, no, base 1 plus base 2 times height divided by 2.
Yes, but depending on how your trapezoid looks like. Our trapezoid is this way. So it's going to be 1/2 times the base times height 1 plus height 2. Because your formula, so Jonathan, your formula is more for like this. Yeah, but it's the same thing. But basically, we're going to take height 1 and height 2 and add it together. So for this one, this is not going to help us at all because our height, we have 2 heights. All right, so well, let's go ahead and draw how this looks like. So between 1 and 2, we're going to draw a trapezoid with height 1 and height 2, and then just kind of draw like that. Between 2 and 3, we're just drawing a trapezoid. So you can see that this is the best approximation for this graph, at least. All right. So between interval 1 and 2, what we're going to do is we're going to find the area of that trapezoid between 1 and 2. So according to the formula, it's going to be 1/2 base is 1. Height 1 is square root 1, which is 1. And then height 2 is square root 2. Between 2 and 3, 1/2 base times height 1 plus height 2. So base is still 1 because the length, the width didn't change. The height is square root 2 plus square root 3. Okay, and then area 3 is also 1/2 times 1 times square root 3 plus square root 4. And so same thing with the last one. Now, if you wanted to calculate the area, you would have to add up all those numbers, and that's kind of annoying because you have all this 1/2 stuff going on, right? So let's think about how we can make this a little easier. Obviously, when we add them together, you can see what will we can factor out, right? So we can factor out the 1/2, right? And then if you look at the numbers, 1 happens once. After that, all these numbers happen twice, right? And then the last number only happens once. Yeah? Okay, so what you can do is the area of the trapezoid, using the trapezoid rule, is 1/2 times the first height, and then after that, everything doubles. And until the last height, you only have one of them. So I don't know if this will be a little easier for you for calculation, but that's how this one works. Okay, so go ahead and calculate the height, the area. Let me know when you're done. Okay, what is the area? Okay, 7.6764. Okay, now let's talk about this trapezoid rule a little bit more. Trapezoid rule is actually very interesting because the trapezoid area is actually the average of the left plus the right. And you can prove it to yourself, just kind of take the formula and then work it out, but it's the average of the left and the right. All right, now that we established the basis for left, right, midpoint, and trapezoid, we're going to solve problems where we are not going to fill out the entire table. You're just going to do it from what you understand of the rules or the areas, and just do it on your calculator. All right, so don't worry about copying down the entire problem, just copy down the essential parts. You have this function, 1 over x. Estimate the area of the region bounded by the graph of f. So you want the area bounded by the graph f, the x-axis between x equals 1, x equals 2, and you want to use 4 rectangles and a right Riemann sum. And then they want you to figure out whether it's an overestimate or underestimate or overestimate of the area. Okay, so you have all the information you need to find the right Riemann sum. Go ahead and do that. Okay, so let's go over this one together. First, you should figure out how long or how wide your base is. So that is b minus a over n, which is 2 minus 1 over 4. That is 1/4 or 0.25. So then what you want to do is kind of look at your intervals, and you want the right-hand side. So basically your interval, if you draw it into 4 equal shares, left is, on the leftmost part is 1, and then 1.25, 1.5, 1.75, and then 2. What you're doing is you're taking the right-hand side. So then the right-hand approximation is going to be 0.25, which is the base, times the height. Height using the right-hand side of the interval, so that is 1 over 1.25 plus 1 over 1.5 plus 1 over 1.75 plus 1 over 2. And then just add that all together. 0.6345. Okay, is it a overestimate or an underestimate of the area? Huh? Overestimate?
It's an underestimate.
Underestimate. Because 1 over x is like this, right? So this is the graph looking like this. You're on the right-hand side, so the graph is decreasing. Decreasing means that if you are using the right-hand side, you're using smaller numbers than what it should be, then you're going to have an underestimate. All right, let's try another problem. This problem has a table. Okay, suppose the function f is positive on the interval 6 to 24. Selected values of f of x are given in the table. So they give you some values of the function. So you want to copy that down. And they are saying that R is this region that's bounded by this graph, the x-axis, and the lines from x equals 6 to x equals 24. Find a trapezoidal approximation for the area of R using the subintervals defined by the table. Okay, so let's look at the table for a minute. The x values goes from 6 to 12 to 20 to 24. Is it an equally spaced out interval? No. Okay. So it is not, but they want us to use whatever rule they want us to use anyway, so we use it anyways. Just know that you cannot use those shortcuts that I showed you where they had equal base because the bases are different. So you have to calculate each trapezoid area by itself and then add it together. Makes sense? Okay, so I don't know how this looks like. So what is it? 6, 5, 6, 5, 12, 7, 24, 24, 7. So something like this, we don't really know how this looks like, but all we care about is this trapezoid. Okay, notice there are only 3 trapezoids. So you need to find the trapezoid for the area for 3 trapezoids and add them together. Okay, go ahead and do that. Okay, so we're just taking the area for each trapezoid. So 1/2, first base is 6, and then the height is 5 plus 7, plus 1/2 times 8, which is the second base, and then 7 plus 4. And then the last one's 1/2 times base, which is 4, and then 4 plus 7. Okay, the answer is 102. Okay. So any questions for anything we learned today? Okay, we learned 4 methods: left, right, midpoint, and trapezoid. And we learned how to divide an area into different amounts of intervals if that's what they want us to do. And we kind of learned how to do this without actually drawing the graph and writing out a chart. Any questions for today? Okay, so let's talk about the quiz tomorrow. So tomorrow, it's just going to be yesterday's stuff and today's stuff, and no calculator. Okay, so I'll give you numbers that's easy enough to calculate by hand, so you don't need a calculator. Should be pretty easy. I think most of you will finish under 10 minutes.